Hi there, this video is going to go over an introduction of the polar coordinate system. In the polar coordinate system, instead of having an x-axis and y-axis like we do in the rectangular system, instead we have a pole, which is just a fixed point, and we have a ray, which we call the polar axis, and it has its initial point at the pole. So each point P in the plane is labeled with polar coordinates r theta, where r is the directed distance from the pole to the point, and theta is the angle in standard position with terminal side OP. So let's take a look. So here's an example of what polar coordinates would look like. Here we have the pole, which is a point, and we're labeling it O. And then this is the polar axis. It's just a ray. And then to look at a point called P, in this case, we have to consider two things. We have to consider the distance that the point is from the pole. That's what we call R. And then we also consider the angle made with the polar axis. That would be theta. So let's take a look at an actual example. Okay, before we graph the point 2 comma pi over 3, I want to just remind you that the polar coordinate system has a pole, which is right there, and it has a polar axis, which is the ray coming out from the pole, like that. Okay, so now let's look at this specific point. Let's look first at the R value, which is 2. That means the point that we're looking at is going to be 2 units away from the pole. Our point is going to lie somewhere along this circle because all of these points are exactly 2 units away from the pole. So you can see why the concentric circles are helpful, because it quickly lets us see the points that are a given distance away from the pole. Now let's take a look at the angle pi over 3. What that means is we need to find the angle. Here's the polar axis, and if I want an angle of pi over 3, that's right about here. Think back to our unit circle. What we have now is we have got to put our point on 2 units along that angle. So this point right here, this is 2 units away from the pole, and it's along an angle that is pi over 3 radians. Now for this next point, you'll notice that r is 3, which means my point is going to be somewhere on this circle, because this every point on this circle is 3 units away from the pole. Now let's look at the angle. The angle that I need to consider is negative 3 pi over 4. We know that negative means there is a rotation that is clockwise. So if I look at my polar axis, and then I need to go negative 3 pi over 4, that's going to put me over here. So this angle right here, that's my negative 3 pi over 4, which means if I consider that my point is 3 units away from the pole, and it's at an angle of negative 3 pi over 4, the point that I'm interested in would be this point right here. This is the point 3 comma negative 3 pi over 4. Okay, let's look at another example. This is the point 3 comma 5 pi over 4. Because of the 3, we know that it's going to be on the third ring. And then when we look at the angle of 5 pi over 4, we just need to find that. So here's the polar axis once again. Now a rotation of 5 pi over 4 radians going counterclockwise. This would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 is right here. So this angle is 5 pi over 4. So I just need my point to be on the third ring along that angle. So here's the point, 3 comma 5 pi over 4. Okay, I want to do one more. We've done an angle that had a positive r and a positive angle, a positive r and a negative angle. So let's take a look at what happens when we have a negative r and a positive angle. So the first thing I'm going to do, so you notice that I've got a negative 3 here. So what I'm going to do is I'm going to first set up my angle. So I'm going to look and see where that pi over 4 angle is. Here's my polar axis. Pi over 4 would come right out here. Okay, so that's a pi over 4 angle. You'll see why I made it a dotted line in just a second. Now before we graph our point and we take a look at the r, you need to remember that r is a directed distance, which means if r is negative, you take a look at your angle, in this case pi over 4, and you shoot the opposite direction, and then look at your number 3. The absolute value of this is 3, so I need to go 3 units, but notice that I went in the opposite direction that my angle pi over 4 would have dictated. Okay, here are the last 3 that we graphed. I want you to notice that even though the coordinates were different, the points that they graphed to were exactly the same. That's something that's a little different from what we're used to. Now, because of our study of trig, you know that any angle has infinitely many ways to write it. If I take, for example, 5 pi over 4, which is this angle, if I add a rotation to that, I can go all the way around the circle and end up at the exact same place. That angle is 2 pi plus 5 pi over 4. And if I think of the 2 pi as being 8 pi over 4, that's the angle 13 pi over 4. So I could easily replace that angle with 13 pi over 4. In actuality, I could add multiples of 2 pi in either direction, and as long as I end up right here and go 3 units out, I will get the same point. Now, if I want to use a negative r, then my angle must be coterminal with pi over 4. So I could use pi over 4 plus any multiple of 2n pi, any number of trips around the circle. As long as I end up at pi over 4, then pairing it with a negative 3 will give me that same point. Okay, let's see the relationship between the polar coordinate system and the rectangular coordinate system. First of all, in the polar coordinate system, we have the pole. In the rectangular coordinate system, that would correspond to the origin. In the polar coordinate system, we have the polar axis. And in the rectangular coordinate system, that would correspond to the positive x-axis. So now let's take a look at a point. In the rectangular coordinate systems, that would be the point x comma y. X represents the horizontal distance, y represents the vertical distance. If I want to consider that same point in polar coordinates, I would look at r as being the distance from the pole to the point, and theta as being the angle. So now let's take a look at some right triangle trig to get a relationship between the two systems. I've got a right triangle right here. The hypotenuse is r and the legs are x and y. So first of all, because of Pythagorean's theorem, I can write down leg squared plus leg squared equals hypotenuse squared. So in this case, it's x squared plus y squared equals r squared. Also, I can take a look at SOHCAHTOA and the three different trig functions they represent. So I've got the sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse. And the tangent of theta is opposite over adjacent. Now I'm going to do one thing here. I'm going to take these two top equations. I'm going to multiply both sides by r so that the r's cancel, and I get y equals r times the sine of theta. And I'm going to do the same thing here to clear the fractions so that I can solve for x, and I get x equals r cosine theta. So I'm going to take all of these pieces of information and put them together. I've got x squared plus y squared equals r squared, y equals r sine theta, x equals r cosine theta, and the tangent of theta equals y over x. Those four equations are going to show me how the two systems are related. Okay, so here you have the four equations that we use to relate the polar coordinates r theta and rectangular coordinates xy. So first of all, notice that all of the equations contain something from the rectangular coordinate system. We've got an x, a y, an x and a y, and an x and a y. Then if you look for the polar coordinate systems, we've got, this one has an r and a theta, an r and a theta, and an r. So in every single one of these equations, there's a relationship between something in the polar coordinate system with something in the rectangular coordinate system. Okay, let's use our equations to convert the point 3 comma pi to rectangular coordinates. Well, the two equations I'm going to need to look at are x equals r cosine theta and y equals r sine theta. So x is going to be r, which is 3, times the cosine of theta, which is pi. So we know that the cosine of pi is -1, which tells me the x-coordinate is -3. Over here, r is 3, and now I have the sine of pi, and we know that the sine of pi is 0, so the y-coordinate is 0, which means my ordered pair is going to be the point -3, 0. So you can see by my rough little drawing here that the point 3 pi in the polar coordinate system is going to be exactly the same as the point -3, 0 in rectangular. Okay, let's look at another one. If I have 4 pi over 6, I'm going to do the same thing. X equals r cosine theta. So I've got x equals r, which is 4, times the cosine of pi over 6. So x equals 4 times radical 3 over 2. So I end up with the 2 cancels in here, and I get 2 radical 3. And now we'll do the same thing with y. Y equals r sine of theta. So I've got y equals 4 times the sine of theta, which is pi over 6. And since the sine of pi over 6 is 1/2, 4 times 1/2 is 2, and my point is 2 radical 3, comma, 2. Okay, now let's go the other way. Let's convert the point -1, -1 to polar coordinates. So to do that, I'm going to need to start with this. The tangent of theta equals y over x. So that means the tangent of theta is -1 over -1, which is 1. Now I'm using this for x and this for y. So then I have to take a look at, okay, where does that happen on the unit circle? If the tangent of theta equals 1, thinking about the unit circle, the tangent equals 1 here at pi over 4, and then straight across the circle at 5 pi over 4. So there are two places that have the tangent equal to 1. So which one do I want? Well, where's our point at? In the rectangular system, if I'm looking x and y, the point -1, -1 is right here. So since this point in the rectangular coordinate system is in the third quadrant, and this angle is also in the third quadrant, I'm going to use 5 pi over 4 for theta. Okay, so now I need to find r. So I'm going to use my other equation, x squared plus y squared equals r squared. And since I know both x and y are -1, I'm going to get 1 plus 1 equals r squared, which means r squared is 2. And if I take the square root of both sides, put in my plus or minus, I get r equals plus or minus the square root of 2. So which one of those do I use, the plus or the minus? Well, that's going to depend on the fact that you've got your angle here. If you're going to use the 5 pi over 4 angle, then you need to go 2 units along that angle, or excuse me, radical 2 units along that angle. So if I'm going to use the point and use the angle 5 pi over 4, then I need to use the positive radical 2 to go with it. Now, if I want to use pi over 4 as my angle, so I want to have the pi over 4 here. Well, since the point that I'm interested in is over here, and I'm not using the quadrant 3 angle, I'm going to have to use, if I use the pi over 4 angle, then that necessitates that I have to shoot in the negative direction, which means negative radical 2 units for my r. So kind of to summarize that, if you're going to use the angle that matches the same quadrant as your point, then you're going to want to use the positive r value. If you're going to use the other angle that has that same tangent, then you're going to need to use the negative r because you have to shoot the opposite direction. This is the angle for the pi over 4, but my point is in the opposite direction of that. So that requires that I use the negative radical 2 for my r. We've looked at how to convert coordinates from polar to rectangular and rectangular to polar, but we also want to take the entire equation and be able to convert it from one system to another. So it's pretty easy to go from rectangular to polar. You just need to use your two equations, x equals r cosine theta and y equals r sine theta. So what happens is over here where I see the y, I'm going to put r sine theta, and where I see the x, I'm going to put r cosine theta. So let's do that. So in place of the y, I'm going to put r sine theta, and in place of the x, I'm going to put r cosine theta, and that quantity was squared. So I get r sine theta equals r squared cosine squared theta. Now when you're in polar coordinates, you want your equation to look like this. R equals everything else. Now you notice that I've got an r in this term, and I've got an r squared in this term. So I can't simply solve for r because this is actually a quadratic. So what I need to do is to get all of the r terms on the same side, and then I'm going to pull out a greatest common factor of r. So I've got r times the quantity sine theta minus r cosine squared theta equals 0. So I set each factor equal to 0. So r is 0, or the sine of theta minus r cosine squared theta is 0. Now, if r is 0, then I just get a point. And I know that this is not just a point. So I'm going to cross out the r equals 0 and just look at the rest of it. I get this. And now I can divide both sides by the cosine squared of theta, because then I have r by itself, and I have r equals the sine of theta over the cosine squared of theta. Okay, so you can leave this as your answer, or you can take it one step further, because I know that 1 over the cosine squared of theta would be the same as saying r equals sine theta secant squared theta. So that is also a correct way to write it, as long as it is solved for r. Changing an equation from polar to rectangular takes a little more ingenuity. So let's take a look at this one. If it tells me that r equals 3, and it doesn't tell me anything about theta, then theta can be anything. So think of all the points in which r equals 3. If I were to graph that, all the points where r equals 3 would be all of the points that are 3 units away from the pole. And that is going to be a circle of radius 3. All of these points are 3 units away from the pole. In other words, r equals 3. I can use any angle I want because this doesn't tell me anything about theta. So let's take what we know about this and write an equation. The equation for a circle centered at the origin is x squared plus y squared equals r squared. And in this case, r is 3, so my equation is x squared plus y squared equals 9. Okay, let's take a look at theta equals pi over 6. It doesn't tell us anything about r, but it tells us that the angle is pi over 6. So let's take a look at just what it would look like if I drew the polar axis. Here's my polar axis, here's my pole. If the angle is pi over 6, that's about right there. So this is pi over 6. Now, if r can be anything, let's say r is 1. That would be roughly this point. If r is 2, r is 3, r is 4, r is 2.5, r is 1.5, r is 1/4, and you see what we're going to get is all the points along this line. Now, if I also include negatives, here's r is -1, r is -2, -1.5, -1/2, -3. So what happens, since r can be anything, what I'm going to end up with is a line that is going to have an angle of pi over 6. So what does that look like in terms of the x and y coordinate system? Well, I know that the tangent of theta equals y over x. All right, now I've already figured out that my angle is pi over 6. So that means the tangent of pi over 6 is equal to y over x. And I know from working out on the unit circle that the tangent of pi over 6 is radical 3 over 3. So now I've got an equation that only has x and y in it. Now, if I'm going to rectangular coordinates, remember that we want something that looks like y equals some stuff. So I would say y equals whatever. So all I need to do to make that happen here is multiply both sides by x, and I get the equation. My x's cancel, and I get y equals radical 3 over 3 times x. Now notice something about this. This is the equation of a line. Think y equals mx plus b, where the slope is radical 3 over 3. Okay, let's take a look at an equation that has both r and theta in it and change it to rectangular coordinates. Okay, so let's see. I know that I've got x equals r cosine theta, y equals r sine theta, tangent of theta equals y over x, and x squared plus y squared equals r squared. Those are my tools. So I need to find something that I can substitute. Now, notice that none of these have secant in them. There's not a secant in any of them. So I think what I'm going to do is I'm going to take this secant and change it to 1 over cosine. So that's going to look like this. R equals 1 over cosine of theta. Now I don't know what else to do, so how about if we just clear the fractions and see if that helps. Cosine of theta, cosine of theta. So what I end up with, after the cosines cancel, I end up with r cosine theta equals 1. And that's great because anytime you can come up with an r cosine theta, you can change it to x, which means this equation turns into x equals 1. Okay, now I'm going to show you two ways to do the same problem. One is a little more intuitive than the other. So to start with, when you look at this one, you might notice that you've got an r squared, which we know from this equation I could change to x squared plus y squared right off the bat. I might want to do that eventually, but I think right now I'm going to focus on dealing with this first because that's the sine of 2 theta, which does not match either one of these substitutions because the argument is wrong. So I'm going to take the equation and I'm going to write it as r squared equals 1 over 1 minus 2 sine theta cosine theta. So why did I do that? Well, I know that, and I'll write it over on the left side here, that the sine of 2 theta, this is just a formula, equals 2 sine theta cosine theta. Okay, so coming back over here, I'm going to multiply both sides by 1 minus 2 sine theta cosine theta because I want to clear the parentheses. I want to clear the fraction. Okay, so that leaves me with r squared minus 2r sine theta cosine theta equals 1. Okay, so now if I look at, oops, sorry, this is an r squared. Now I'm looking at this right here, and I'm going to rearrange the terms because I see I need an r cosine theta and an r sine theta. And I see over here in this product, I've got an r squared and a sine and a cosine. And this is a product, so I'm just going to rewrite it. And I get r squared minus 2r sine theta times r cosine theta. Because if this is all multiplication, I can rearrange the terms however I want. Now this guy right here, r sine theta, I know is y, r cosine theta is x, so I end up with, and I might as well, while I'm at it, change this to x squared plus y squared. So I end up with x squared plus y squared minus 2 times y times x, and I'm going to bring that 1 over to the left, and this is my final answer. Okay, now I'm going to do the same problem with a little bit more direct substitution. Now up here, if I take this equation and solve it for cosine, I'm going to get the cosine of theta equals x over r. And for this one, I get the sine of theta equals y over r. What that does is it allows me in any polar equation to take out the cosine and take out the sine and put something different in. So let me show you how that works. Now first of all, we need to do that same substitution we did for the sine of 2 theta. So I'm looking at r squared equals 1 over 1 minus 2 sine theta cosine theta. Okay, now I'm going to leave the r squared as it is, and I did that in the last problem, and the reason I do that is it's easier to do the algebraic manipulations with an r squared instead of an x squared plus y squared. So I usually will leave the r squared as it is until the very end, until I've gotten rid of any thetas. Once I get rid of the thetas and get it cleaned up, then I'll look for the r squareds and change them into x squared plus y squared. So now looking at this equation, I see that I've got a sine x here and a cosine x, and I can make substitutions right now, or I could clear the equation of fractions. So let me kind of show you both ways. If I make the substitution, I get 1 minus 2, take out the sine x and put y over r, take out the cosine x and put x over r, and I get a complex fraction on the right side. So I think what I'm going to do is I'm going to back up, and instead of having a complex fraction on the right side, I think what I'll do is I'm going to multiply and clear the fraction like I did in the last example. So I'm going to multiply both sides by 1 minus 2 sine theta cosine theta. And they cancel on the right, and I end up with, and I'm going to multiply through, so I'm going to get r squared minus 2 r squared sine theta cosine theta equals 1. So now let's say that you didn't notice that combination of r sine and r cosine, and you're just looking at this. Well, now here's where I would make the substitution for the sine and the cosine. Now remember I said don't worry about the r squareds until you have gotten rid of the sine theta cosine theta. So now let's make that substitution, and I've got r squared minus 2 r squared. Now the sine is y over r, the cosine is x over r, and it equals 1. So I have r squared minus 2 r squared yx over r squared equals 1. The r squareds will cancel, and I end up with r squared minus 2xy equals 1. Now's the time to make a substitution here and get x squared plus y squared minus 2xy minus 1 equals 0. Okay, so same answer as we had before. But in this case, I did a substitution to get rid of the sine theta and the cosine theta. You could do it right away and deal with the algebra of the complex fraction, or this might be a better route, which is clearing the fraction first. Okay, in this problem, because we have an r instead of an r squared, I would maybe choose, instead of trying to manipulate things, I think I would try the more direct approach. I would write cosine theta equals x over r, and sine theta equals y over r. And I would make that substitution right away. So what that looks like then is r equals, now instead of the sine of theta, I'm going to put y over r. And then instead of the cosine of theta, I'm going to put x over r. Okay, so now if you look at this, the natural step to do next would be to clear the fractions. So the common denominator is r. I'm going to multiply all the way through by r. And that works out really great because I get an r squared. And r squareds are great to have because we can make a substitution. I get r squared equals, these r's cancel and I have y. These r's cancel and I have x. I'm going to make one last substitution and I get x squared plus y squared equals y plus x. So if I put everything on one side, the correct format would be this. Oops, equals 0, and that would be the final answer. So if you have just an r and then some sine theta, cosine theta, or whatever, I would probably try and do a substitution like this and see if clearing fractions gets me something closer to my goal.